Assalamu alaikum. My name is Ali Khan, roll number 21TE77, and our instructor is Dr. Muhammad Jamil. Today I want to discuss adaptive filters and their applications of the chapter number 9 and in the LI 10 book of DSP. So now I want to use ChatGPT to explain these topics. So now for my convenience I will move toward ChatGPT. So in ChatGPT, first of all, I want to define adaptive filters. Adaptive filters are dynamic systems that adjust their parameters to minimize a defined cost function, typically an error signal. Unlike static filters, adaptive filters can change in response to variation in the input signal, making them suitable for non-stationary environments. Now we move toward Wiener filter. So the Wiener filter is a type of linear filter used to produce an estimate of a desired signal by minimizing the mean square error between the estimated and the desired signals. The theory is based on the statistical properties of the signal and noise. So here is the key points of the adaptive filters. Of the Wiener filters, objective to minimize the mean square error mean (MSE) and assumption noun autocorrelation and cross-correlation function of the input signal and noise. So here is the key point solution involves solving the Wiener of equation. Now here is some algorithms of the adaptive filters. So the first one is steepest descent algorithm. The steepest descent algorithm is an iterative method for finding the minimum of a function in the context of adaptive filtering. It is used to minimize the mean square error by adjusting the filter coefficient in the direction of the negative gradient of the error surface. So here is some key points of the steepest descent algorithm. So these formulas are used for steepest descent algorithm. So the second one is the least mean square algorithm, mean LMS. And the LMS algorithm is a simplified version of the steepest descent algorithm used in adaptive filtering to minimize the error signal. It approximates the gradient vector using the current data sample. So here is some key points of the least mean square mean LMS algorithm. So now we move toward the third number algorithm. Recursive least squares mean RLS algorithm. So the RLS algorithm provides a more efficient solution by recursively updating the filter coefficients to minimize the least square error. It typically offers faster convergence compared to the LMS algorithm. So here is some key points of the recursively square algorithm. The first one is objective, minimize the exponentially weighted least square error. And the second update rule, Vn is equal to W omega n minus 1 plus K of n into E of n. Kalman rule, the third one is Kalman rule. Again, K of n is equal to phi of n minus 1 into x of n over lambda plus x of tau into n p of n minus 1 into x of n. The third one is error signal, which is x of e of n is equal to d of n minus omega power tau into n minus 1 into x of n. The third one is covariance matrix update, and here is some applications of the adaptive filters. So the first application is the noise cancellation. Adaptive filters are extensively used in noise cancellation applications where the objective is to eliminate unwanted noise from a signal. For instance, in audio processing, adaptive filters can remove background noise from speech signals. Second one is system modeling. Adaptive filters can model unknown system by adapting their parameters to match the system's behavior. This is useful in applications such as system identification and adaptive control. The third application is line enhancement. Adaptive filters enhance specific signal components by suppressing noise. For example, line enhancement techniques can improve the quality of communication signal by removing interference. So now we move toward cancelling periodic interference says using linear prediction. So the linear prediction can be employed to cancel periodic interference in signals. Adaptive filters predict the interferences and subtract it from the original signal, effectively cancelling it out. Electrocardiography mean ECG interference cancellation. So in ECG signal processing, adaptive filters remove power line interference and the other artifacts from the ECG signals to provide a clearer representation of the head's electrical activity. So now we move toward echo cancellation in long distance telephone circuits. Adaptive filters are crucial in echo cancellation for telecommunication system. They estimate and subtract the echo from the received signal, enhancing the quality of long distance telephone calls. So now we move toward summary of the adaptive filters. So adaptive filters supported by algorithms like LMS and RLS offer versatile solutions for signal processing applications, particularly in environments where signal characteristics can change over time. Their ability to minimize error and adapt to new conditions makes them invaluable in noise cancellation system modeling and interference mitigation. So now we move to word or book. So here in book, the same topic we have discussed already, and the adaptive filters is a digital filter that has a self-adjusting characteristic. It's capable of adjusting its filter coefficient automatically to adapt the input signal via an adaptive algorithm. Adaptive filters play an important role in modern digital signal processing. So this is an important role in modern digital signal processing. So now we move toward, so here is some examples. The first, the DSP consists of two analog to digital channel. The first microphone with ADC is used to capture the desired speech SON. However, due to a noisy environment, the signal is contaminated and the ADC channel produces a signal with the noise. That is, T of n is equal to S of n plus n of n. And the second microphone, which is and the ADC channel, the second microphone is placed where only noise is picked up, and the second ADC channel captures noise x of n, and which is fed to adaptive filters, and LMS algorithm is used for microphone. So here some topics are we are discussed already. Here is the Wiener filter theory and adaptive filters. All these we discussed earlier. There is no need to discuss now. So this is also is an algorithm we have discussed earlier, and this is the last mean square algorithm. This is also we discussed earlier, and recursive least square algorithm. This is also we discussed earlier, and here is applications of the adaptive filters, which is noise cancellation, system modeling, and line enhancement. So this is all about adaptive filters and their applications. Thanks for watching this video.